Okay, this podcast is going to cover the basic router config for a Cisco router for ipv6. So I have no config on my router. No, I hit the wrong thing. Control C. I did not want to enter setup mode. That's what setup modes looks like if you accidentally enter it when you don't want to. I didn't want to enter it. So my router ever finishes this. So enable conf, let's first look at our running config. If you look at my config, I don't have anything in here just yet. So I'm going to configure some interfaces. All right, so conf t int fa0/0 ipv6 address. Right, and you need a question mark. You can put some stuff. IP address, prefix length, and auto config. We're not going to do auto config because we don't have any other server on the network giving out :1/64. So if you watched the previous podcast, you know that I set up a Windows machine with FC01:1:2 on the /64 network. So I set my router interface to be on that same network, and I can also need to do no shutdown. I'll go ahead and set up my FA01 for fun. All right. If we're doing router interfaces, we need to put the IPs in different subnets. So if my other one was in the FC011 subnet, I'll make this one the FC012 subnet. Do no shutdown. All right, and then we need an ipv6 route. ipv6 route. And I'm pretty sure the way we need to do that is we're going to do a default route. And for ipv6, the special network for anything is ::0. I thought. All right, and then the ipv6 address of the next hop. So in theory, if we had configured a serial interface to connect to another router, then we would put the IP address of the next hop in there, and that would be it. So I forgot to do a serial interface, so let's go ahead and do a serial interface for fun. So in this case, I set my serial interface to FC01:3:2/64, which in theory, I would have another router at the other end of the serial interface. Based on my route I have added, that IP address of that other router will be FC01:3:1. So if I were to configure both routers and connect them together, I had to put a IPv6 default route on this router pointing to the other router, and I had to put one on the other router pointing to this router. So the only thing left to do is to tell our router it is a router. By default, our version of iOS does not route IPv6 packets, so we need to enable it to route packets with this command, IPv6 unicast routing. I'm actually going to start Wireshark on my Mac so that we can hopefully catch the router advertisement. Oh, there it is. choose application. It's the first time it's done that. Alright, maybe I'm not going to start Wireshark on my Mac. I've never seen that little nonsense before. So, let's see. I'll go ahead and turn it on. And we will... So if we look at my interface, I have IP addresses in the FC01 network, which means that my router sent out router advertisement messages, and/or my host sent out router solicitation messages. You will be capturing those and looking at those in the lab, basically trying to determine what happens. Essentially, a router solicitation message is your host saying, hey, yo, are there any IPv6 routers out there? And if your router hears that, it will respond, hey, I'm an IPv6 router, and it will send you some information, and you can auto-configure your IP address information based on that. We haven't done the DHCP chapter yet, but once we do the DHCP chapter, we will learn that there are 4 things that a host needs to communicate on a network. It needs its IP address, it needs to know the correct prefix length for that network, it needs to know its gateway, and it also needs to know its DNS server. So your job is to look at the information that is being provided in the router advertisement message from the router and determine if all 4 of those pieces of information are being provided. And if they are not being provided, what is missing and how you can make it be provided. So in the lab, we'll actually, after we configure the routers, we'll actually capture those router solicitation advertisement messages.